Mr. Harmless here, and I'm going to give you some unofficial formulas. Let's put that off to the side. Okay, so here are some unofficial formulas for dealing with a right triangle with an altitude. You could call them harmless formulas, right? They could be harmless. They might be helpful, but they're made by me, and I hope they help you. This is how I memorized this when I was in school. The formulas are very simplified versions of what you actually need to know, but it was an easy way for me to keep it in my memory so I would know what to do. Okay, so the first one has to do with this. It's with a right triangle with an altitude. The altitude is the geometric mean, okay, of the two segments of the hypotenuse. So I memorized it by thinking about this. I said the altitude, and I put that here and here. The altitude is the geometric mean, right? Because that's where geometric means go, here and here, of two things. And the two things it's geometric mean of are the two segments of the hypotenuse. So one of those segments is here. The other segment is here. Okay? So segment over altitude equals altitude over segment. Okay? The other formula has to do with the leg. Now, since there's two legs, I have two versions of it here. So let's start with this green leg over here. The leg is the geometric mean. Okay, so that's why I put it down twice. The leg is a geometric mean of two things, and the two things it's the geometric mean of is the hypotenuse and the segment of the hypotenuse that's next to that leg. So between these two segments, the ones that's next to this particular leg is this blue one right here. So see, in my mind, I'm saying hypotenuse leg, leg segment, right? And sometimes I would say segment adjacent. Hypotenuse leg over leg equals leg over segment adjacent. Hypotenuse over leg equals leg over segment adjacent. And this is what I memorized. I still remember it. The other leg, since there's another leg, we have to represent it as well. The leg is a geometric mean, right? So if I'm using this leg, that's what I would put there and there. Leg is a geometric mean of two things, the hypotenuse and the segment of the hypotenuse adjacent to that leg. So the hypotenuse, right, is this whole side here, hypotenuse, and the segment of the hypotenuse that's next to this leg would be this orange one right here. So I'm going to put segment adjacent. All right, so I'm giving this to you, not because these are official formulas, not because I would ever say, this is how you ought to memorize and learn this. I'm giving this to you because this is what was helpful to me, and I'm hoping that it might be helpful to some of you, and maybe even just having this picture representation with the color coding so that you know what goes with what might be somewhat helpful. And let's see if we can do a couple of examples using our unofficial formulas. Okay. So in this particular problem, I have more than one thing here. So let's say I said, well, I want to try with this problem. I want to try this first formula, right? So you don't come at it thinking, I know what formula I'm going to use. Sometimes you come at it going, I don't know which one I'm going to use. So let's try one, right? So the altitude is the geometric mean of the two segments of the hypotenuse. So the altitude in this case is y. So the altitude is the geometric mean. So that's why I put it here and here. See, altitude, geometric mean of the two segments of the hypotenuse. One of those is 24. The other one is this one right here would be x, the whole thing, minus 24. Okay, so now you may not have needed to write this out to figure this out, but as soon as I started doing this, I knew, like, wait a minute, I'm going to have two variables here. I'm not going to be able to solve this. So I said, okay, well, let's not do that one first. And so you wouldn't have to erase it. I'm going to erase it just so that you're not wondering what's going on. Okay. So then I go, okay, well, let's try another one here. Let's try this hypotenuse leg. So I'm going to go with the leg that I actually have a number for. So the leg is the geometric mean. So it means it's going to go here and here. Leg is the geometric mean of two things, right? Leg, hypotenuse, and segment adjacent. So the hypotenuse, the whole thing, x. Segment adjacent to the hypotenuse is 24. So notice following that pattern, I'm able to come up with this. Now this is one that I can solve. I'm looking at it right away and I go, okay, hey, this is something I can solve. So I can cross multiply and solve. So 27 times 27, x times 24, and then divide, and you're going to figure out what x equals. And then once you have x, well, then you'll be able to figure out what this equals, and then you'll be able to figure out what the y equals because we had that formula a minute ago, and then you could plug in, to find z. So there's a lot of different ways to come at this, but sometimes there's one particular way that you kind of have to go with to get it started. So let's go ahead and work this out. 27 times 20, I'm going to have to grab my calculator here. And I know it's off screen. You can't see it. 27 times 27 is 729. So let's put that right here. 27 times 27, 729. X times 24 is 24x. Divide both sides by 24. So 729 divided by 24, and I'll grab my calculator here. Divided by 24. And it doesn't come out evenly. 30.375. So x. All right, so divide by 24, and so I'm going to get my x. On this side, x equals 30.375. Now, in the directions, it would probably say something like round to the nearest tenth, which means I'd put 30.4. I usually don't round in the middle of a problem. Like I know that x is going to be 30.4 if I'm supposed to round. If not, I'm going to leave it like this, at least as long as I'm working out the rest of my problems. So now I can always figure out what the rest of this is. So for example, I can figure out what this little segment is right here because I know x, the hypotenuse, is 30.375. So I'm going to take that minus that 24 to figure out what the other segment of the hypotenuse is. And I get 6.375. Here, let me put that up there for you. Okay, so 6.375 is going to be this little piece right here. So now if I wanted to find the altitude, I could use it. Go back to this one. Altitude, right? Y equals the two segments of the hypotenuse. One of them is 6.375. The other one is 24. And so now I can cross multiply. I get y squared equals, and then 24 times 6.375. Definitely have to use my calculator here. Times 24. And I get 153. So here we have 153. That came out fairly easy. Take the square root of both sides, and I get y equals the square root of 153. And if so, simplify. If not, you can work it out. And then you just have the last leg defined. And to find that last leg, we're going to go back to this little formula here. So the leg is the geometric mean. So I'm going to say z. Leg is the geometric mean of the hypotenuse. In this case, I figured out it was 30.375. Segment adjacent, 6.375. And so then I can cross multiply to solve for z. So z squared equals 30.375 times 6.375. Grab my calculator here. 30.375 times 6.375 equals 193.640. So 193.6. Square root both sides, and I get z equals the square root of 193.6. And if I said round, then you'd go ahead and work this out on your calculator. Square root of 193.6. This one down here, square root of 153. So you get your x. X approximately 30.4. Y square root of 153. Square root 153 is 12.4 approximately. So y approximately 12.4. And then z square root of 193.6. Square root 193. I'm going to go ahead and put more of it in there. 640,625. 640,625. Let me see if I can bring that. I got some words in the way here. 13.9 approximately. So z is approximately 13.9. So if it says to round, that's the answers that you would end up getting. And we go from there. So X, Y, and Z. So you can see this is a big problem. Technically, what we're doing isn't that difficult. The problem is remembering what you're supposed to do. And that's why I hope that these little formulas might be somewhat helpful to you. If not, there's other ways to memorize this, but I've never found as much luck with those. Let me know if you need some extra help.